children, welcome back to science class. Hope you are all doing very well. Stay home and be safe. In last class, we discussed about second law of motion. Second law of motion states that the rate of change of momentum is proportional to the applied unbalanced force. In previous classes, we discussed about first law of motion. These two laws of motion explain how an applied unbalanced force change the motion of an object. And it's also help us to determine the third law of motion. It explains when an object exerts a force on another object, then instantaneously the second object applied a force back to the first object. The two forces are equal. The magnitude of two forces are equal, but directions of forces are opposite. Let us talk about some activities. When we place a ball on a table, the ball exerts a force on the table in the downward direction, and the table also applied a force on the ball in the upward direction. These two forces are equal. That means the magnitude of these two forces are equal. That is F1 equal to F2. But the directions are opposite. The directions of these two forces are opposite. From these activities, we state Newton's third law. Newton's third law states that every action there is an equal and opposite reaction. Every action there is an equal and opposite reaction. From this activity, the ball applied a force on the table. In the first case, the ball applied a force on the table. This force is known as action. And the second case, the force is applied on the ball in the upward direction. This is reaction. Okay, what is third law? Third law of motion states that every action there is an equal and opposite reaction. Third law of motion states that every action there is an equal and opposite reaction. We already discussed about what is action and what is reaction. What is action? The force applied by the ball on the table is action. The force applied by the table on the ball is called reaction. Let's talk about another activity. There are two spring balance given there. We named as balance B and balance A. The balance B is connected to a rigid body like a wall, and the balance A and balance B are connected each other. When we applied a force on the free end of balance A, we can see that the scales of balance B and balance A shows a same value. അതായത് നമ്മൾ ഈ രണ്ട് ബാലൻസും തമ്മിൽ അങ്ങോട്ട് വലിക്കുമ്പോൾ എ എന്ന് പറയുന്ന ബാലൻസിലെ ഫ്രീ എൻഡിൽ നമ്മൾ ഒരു ഫോഴ്സ് അപ്ലൈ ചെയ്യുമ്പോൾ നമുക്ക് ബാലൻസ് ബിയിലും ബാലൻസ് എയിലും ഒരേ സ്കെയിലിൽ ഒരേ വാല്യൂ കാണാനായിട്ട് സാധിക്കും. When we applied a force on the free end of balance A, we can see that the value showed in the scale of balance B and balance A is equal. അതായത് ബാലൻസ് എയുടെ ഫ്രീ എൻഡിൽ നമ്മൾ ഒരു ഫോഴ്സ് അപ്ലൈ ചെയ്യുവാണെങ്കിൽ നമുക്ക് ബാലൻസ് ബിയുടെയും ബാലൻസ് എയുടെയും സ്കെയിലിൽ ഒരേ വാല്യൂ കാണാനായിട്ട് സാധിക്കും. What does it mean? It means that the balance B applied a force on balance A, and balance A also applied a force on balance B. These two forces are equal, but the direction of these forces are opposite. When a balanced A applied a force on balanced B, this force is called action, and the balanced B applied a force on balance A. This is called reaction. So we say that every action there is an equal and opposite reaction. In this third law, the magnitude of forces are equal. The magnitude of forces are equal. Magnitude of forces equal. The magnitude of forces are equal, but they applied in opposite direction. But they performed in opposite direction. We studied from this activity, that is, the magnitude of forces are equal. But the acceleration produced by these bodies are not equal. The magnitude of accelerations are not equal. Because the force produced by different objects. The force produced from different objects. The different objects have different masses. So, there is a variations of acceleration. We already studied that F is equal to ma. That is, force is equal to mass into acceleration. From this equation, m is equal to F by a. That is, when mass increases, the acceleration also decreases. We already studied that when mass increases, acceleration decreases. Let us see another example. When a gun is fired, the gun applied a forward force on the bullet. The bullet applied a backward force on the gun. After result of this action and reaction, we can see that the gun is recoiled. That means the gun moved backward. The gun moved backward. But the acceleration of the bullet is much more than the acceleration of the gun. Because the bullet is less massive than the gun. In this case, the movement of bullet is action and the movement of gun is a reaction. The another example is when a sailor jump out of a rowboat, we can see that the sailor jump a forward direction and the boat moves in the backward direction. That means the force acting on the forward direction when the sailor jump on the forward direction. And the boat move backward direction. That means the force act on the boat in backward direction. It shows that there is forces are equal. The magnitude of forces are equal. But they are opposite direction. But the forces are applied in opposite direction. The jumping of sailor from the boat is action and the movement of boat to backward is reaction. So we say that third law means every action there is an equal and opposite reaction. For another example is when we walk on the road, our foot exert a force on the road, that is muscular force. And the road is also exert a force on the foot in the upward direction. There are two forces. The magnitude of these two forces are equal, but the directions of that forces are opposite. Consider a big rubber balloon, fill it with a full of air and tie the end of balloon with a band or using a adhesive tape. When a thread is passing through the straw and it is fixed on the rigid body. The two sides of the thread can be fixed on the rigid body. When we remove the tie, we can see that the air move or the air escape from the balloon and the straw moves forward. From this action or from this activity, we see that when the air move backward and the straw move forward or the balloon move forward. That means the force of air move backward and the force of balloon moves forward. Force applied by the air on balloon is forward direction and the force applied by the balloon on the air is backward direction. The force applied by the air on the balloon is forward direction and the force applied balloon on the air is backward direction. The force applied by the balloon on the air is backward direction. So, it is the escape of air is action and the movement of straw is reaction. Movement of straw is reaction. Let us talk about another activity. Take a test tube and fill it with some water and give and the mouth of test tube is closed with a cork. When we heat the test tube, the cork will be escape from the mouth of the test tube. Cork move in forward direction and the test tube recoil in backward direction. That is the movement of test tube is reaction and the movement of cork is action. Next we study about law of conservation of momentum. For this, let us do an activity. Consider two balls. We name that ball A and ball B. They are moving in a same direction with the same velocity. Then the velocity of A is increases than ball B. Then the ball A comes to collide the ball B. The ball A comes to collide the ball B. The ball A comes to collide the ball B. Then the ball A comes to rest and the ball B is moving, continuously moving. From this action, we see that the force of ball A can be conserved or changed fully into force of B. There is no external force acted on them. അതായത് A എന്ന് പറയുന്ന ബോളിന്റെ ഫോഴ്സ് കംപ്ലീറ്റ് ആയിട്ട് എങ്ങോട്ട് കൺവേർട്ട് ചെയ്തു? B എന്ന് പറയുന്ന ബോളിലേക്ക് കൺവേർട്ട് ചെയ്തു. അവിടെ എക്സ്റ്റേണൽ ഫോഴ്സ് ഒന്നും ആക്ട് ചെയ്യുന്നില്ല. A എന്ന് പറയുന്ന ബോളിലെ ഫോഴ്സ് കംപ്ലീറ്റ് ആയിട്ട് B എന്ന് പറയുന്ന ഫോഴ്സിലേക്ക് കൺവേർട്ട്. A എന്ന് പറയുന്ന ബോളിലെ ഫോഴ്സ് കംപ്ലീറ്റ് ആയിട്ട് B എന്ന് പറയുന്ന ബോളിലേക്ക് കൺവേർട്ട് ചെയ്തു. അവിടെ എന്ത് സംഭവിക്കുന്നില്ല? വേറെ ഒരു എക്സ്റ്റേണൽ ഫോഴ്സ് അവിടെ ആക്ട് ചെയ്യുന്നില്ല. From this activity, we conclude that momenta of the two objects before collision is equal to the sum of momenta of the objects after collision. The sum of momenta of the objects before collision is equal to the sum of momenta of the objects after collision. On the former activities, that is when the ball A is collide on the ball B, when the ball A become rest and the ball B is continuously move. This is because momentum of the ball A or the force of the ball A is conserved to the ball B. There is the force is equal. Here the force is equal. There is no external force acted on it. There is no external force acted on it. Here the magnitude of forces are equal. So the law of conservation of momentum states that the sum of momentum of the two objects before collision is equal to the sum of momentum of the two objects after collision. There is no external force acted on it. If there is no external force acted on it.
Newton's third law of motion. Sir Isaac Newton was a 17th century English physicist who discovered 3 laws of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. Notice that if the forces are exerted on different objects, they will not cancel each other. The third law can be used to explain rocket propulsion and the recoiling of the gun. Here are some daily life situations to illustrate Newton's third law of motion. When we walk on the ground, our foot pushes against the ground backward, that's action force, and the ground in turn exerts a force on the foot, that's reaction force, pushing the foot forward. When a man jumps from a diving board, he pushes the board, which is action force, and the board in turn pushes the man forward in the opposite direction, which is reaction force. Birds, while flying, push the air downwards with the help of their wings, which is action force, and the air in turn exerts a force on the bird in the upward direction, that is reaction force. Here is an experiment which proves Newton's third law of motion. Materials required: 2 spring balances of different least count, an iron stand fixed on a table. Procedure: arrange the stand. Take 1 spring balance. Note the least count of the spring balance. 5 divisions is equal to 0.25 n. That is, 1 division is equal to 0.25 divided by 5 is equal to 0.05 n. Fix 1 spring balance to the stand. Now, take the second spring balance and attach it to the end of the first spring balance. Pull the second spring balance away from the stand. As you pull the spring balance, you will feel that the spring balance is being pulled back. Both the spring balances will show the same force. Repeat the process. The 2 spring balances will continue to show the same forces. Tabulate all the readings. So we can conclude that when the second spring balance exerted a force on the first, which was the action force, the first spring balance also exerted an equal and opposite force on the second, which was the reaction force. Action and reaction forces are equal in magnitude but opposite in direction. Action and reaction forces act on 2 different bodies at the same time, so they do not cancel each other. Hence, Newton's third law of motion is verified.
I hope all of you understood this portion. Thank you. See you again.